plan to power a three-phase air conditioning system by connecting a single leg from a generator to the missing phase is not a viable solution and poses significant risks. Three-phase alternating current, or AC, systems are engineered to operate with three distinct phases that are precisely 120 degrees apart. This phase separation is crucial for the proper functioning of three-phase equipment, including air conditioners, motors, and other industrial machinery. Supplying only one phase from a generator disrupts this balanced system. This will not provide the correct voltage and phase relationship needed for the equipment to operate as intended. The air conditioning equipment is designed to have a balanced load across all three phases. Introducing a single phase from a generator creates a severe imbalance. This imbalance can lead to several problems. Firstly, it can cause the motor windings within the air conditioning unit to overheat. The uneven distribution of current can result in excessive heat buildup in certain windings, potentially leading to premature failure of the motor. Secondly, the control systems and other electronic components within the air conditioning unit may not function correctly due to the inadequate or incorrect voltage being supplied. This can result in erratic operation or complete shutdown of the system. Thirdly, the generator itself could be at risk. If the generator is not specifically designed to handle unbalanced loads, it could experience stress and damage due to the uneven current draw. Connecting a generator improperly to a three-phase system can also create safety hazards. If the generator is not synchronized with the existing electrical system connecting, it can cause a surge of current that could damage equipment and pose a risk of electrical shock. The correct and safe approach to restoring power to the building involves repairing the damaged phase of the electrical system. This typically requires identifying the source of the phase loss, which could be a damaged transformer, a broken wire, or a faulty connection. Once the source of the problem is identified, it must be repaired or replaced to restore the proper three-phase power supply. Repairing a damaged phase may involve the following steps. Firstly, a qualified electrician should conduct a thorough inspection of the electrical system to identify the cause of the phase loss. This inspection may involve using testing equipment to measure voltage and current levels at various points in the system. Secondly, if a damaged transformer is identified, it should be replaced with a new or properly rebuilt transformer that meets the specifications of the electrical system. Thirdly, if the phase loss is due to a damaged wire or connection, the wire should be repaired or replaced, and the connection should be properly tightened and insulated. Fourthly, after the repairs are completed, the electrician should verify that the three-phase power supply is balanced and that the voltage and current levels are within the acceptable range. It is strongly recommended that a qualified electrician be consulted to perform the necessary repairs. Attempting to repair a three-phase electrical system without proper training and experience can be dangerous and could result in serious injury or damage to equipment. Furthermore, it is essential to comply with all applicable electrical codes and regulations when performing electrical work. These codes are designed to ensure the safety of people and property. In summary, attempting to power a three-phase air conditioning system with a single leg from a generator is not a safe or effective solution. Repairing the damaged phase of the electrical system is the only way to restore power properly and ensure the safe and reliable operation of the equipment. Consult a qualified electrician to perform the necessary repairs and ensure compliance with all applicable electrical codes and regulations. Understanding three-phase power is fundamental to understanding why a single-phase input will not work. In a three-phase system, three alternating current sources are offset in time by 120 degrees. This arrangement provides a more consistent power delivery compared to single-phase systems, which fluctuate significantly in voltage and current. The 120-degree separation ensures that at any given moment, there is always a significant voltage difference between at least two of the phases, providing continuous power. This is especially important for inductive loads like motors and air conditioning units, which require a consistent power supply to operate efficiently and avoid damage. When a phase is lost, the balance of the system is disrupted. If you introduce a single phase from a generator into the scenario, you are essentially trying to force a single-phase source to mimic the behavior of a three-phase source. This simply will not work because the single-phase source cannot create the necessary 120-degree phase shifts required by the equipment. The air conditioning unit's motor, designed for three-phase input, relies on the rotating magnetic field created by the three phases to start and run efficiently. Without all three phases properly aligned, the motor will struggle to start, draw excessive current, and likely overheat. This can quickly lead to motor failure. Moreover, attempting to backfeed a single phase into a three-phase system can create dangerous conditions. The electrical panel and associated wiring are designed to handle balanced three-phase loads. Introducing a single-phase source can overload certain circuits and create the risk of electrical fires. Additionally, if the generator is not properly isolated from the grid, there is a risk of backfeeding power into the utility system, which can be hazardous for utility workers and could damage the generator itself. Instead of attempting a makeshift solution, the proper approach is to diagnose and repair the root cause of the phase loss. This typically involves testing the incoming power lines, transformers, and circuit breakers to identify the point of failure. Once identified, the faulty component should be replaced or repaired by a qualified electrician. This ensures that the three-phase system is restored to its original balanced state, providing a safe and reliable power supply for the air conditioning unit and other equipment. In commercial buildings, three-phase power is essential for operating large equipment efficiently. It is important to maintain the integrity of the three-phase system to avoid costly downtime and potential equipment damage. Regular inspections and maintenance can help prevent phase loss and other electrical problems. Always consult with a licensed electrician for any electrical repairs or modifications to ensure the safety and proper functioning of the system. In addition to the dangers already mentioned, it's important to consider the impact on other equipment connected to the same electrical panel. When one phase is missing, the voltage on the remaining two phases can become unbalanced, leading to voltage fluctuations that can damage sensitive electronic devices. This is because the loads that were previously balanced across three phases are now forced to operate on only two, increasing the current on those phases and causing voltage drops. Furthermore, the imbalance can create harmonic distortions in the electrical system. Harmonics are unwanted frequencies that can interfere with the operation of electronic equipment, causing them to malfunction or fail prematurely. These harmonics can also increase energy consumption and overheat transformers and other electrical components. Therefore, attempting to run a three-phase system on a single-phase source not only risks damaging the air conditioning unit and the generator, but can also have cascading effects on the entire electrical system. The proper way to address a phase loss is to isolate the problem, repair the faulty component, and restore the balanced three-phase power supply. This approach protects the equipment, ensures the safety of personnel, and maintains the overall integrity of the electrical system. Remember that electrical systems are designed to operate within specific parameters. Deviating from these parameters can create hazardous conditions and lead to costly repairs. Always consult with a qualified electrician who has the knowledge and experience to diagnose and repair electrical problems safely and effectively. The complexity of three-phase systems requires specialized knowledge and tools to troubleshoot and repair. Attempting to fix the problem yourself without the proper training can be dangerous and could void any warranties on the equipment. A licensed electrician will have the necessary equipment to test the system, identify the fault, and make the appropriate repairs. They will also ensure that all work is done in compliance with local electrical codes and regulations. Ignoring the phase loss and continuing to operate equipment on an unbalanced system can also lead to increased energy consumption. Motors operating on unbalanced voltage will draw more current to produce the same amount of work, leading to higher electricity bills. Over time, this increased energy consumption can add up significantly, making it more cost-effective to repair the phase loss than to continue operating on an unbalanced system. In addition, unbalanced voltage can shorten the lifespan of electrical equipment. Motors and transformers are designed to operate within a certain voltage range. When the voltage deviates from this range, it can stress the components and cause them to wear out faster. This can lead to premature failure and the need for costly replacements. Therefore, addressing a phase loss promptly is not only a matter of safety but also a matter of economics. By repairing the problem quickly, you can prevent further damage to equipment, reduce energy consumption, and extend the lifespan of your electrical system. When faced with a phase loss situation, it is important to prioritize safety and take the appropriate steps to address the problem. Never attempt to bypass safety devices or make temporary repairs that could create a hazard. Instead, contact a qualified electrician and follow their recommendations for repairing the system and restoring the balanced three-phase power supply. The electrician's expertise and knowledge will ensure that the repairs are done safely and effectively, protecting your equipment and personnel from potential harm. Remember that electrical systems are complex and require specialized knowledge to maintain and repair. Attempting to work on electrical systems without the proper training and experience can be dangerous and could have serious consequences. Always consult with a licensed electrician for any electrical repairs or modifications. The cost of hiring a qualified electrician is well worth the peace of mind knowing that the work is being done safely and correctly. A commercial building's electrical system is the lifeline of the business. Ensuring its proper functioning is critical to the success of the business. Regular inspections and maintenance can help prevent phase loss and other electrical problems. By taking proactive steps to maintain the electrical system, you can avoid costly downtime, prevent equipment damage, and ensure the safety of your employees and customers. A final point to consider is the potential impact on insurance coverage. If an electrical fire or equipment damage occurs as a result of attempting to run a three-phase system on a single-phase source, the insurance company may deny coverage if they determine that the problem was caused by improper maintenance or repairs. Therefore, it is important to follow proper procedures and consult with a qualified electrician to ensure that all electrical work is done in compliance with applicable codes and regulations. This will help protect your investment and ensure that you are covered in the event of an electrical incident. In conclusion, the proposed plan to power the three-phase air conditioning system with a single leg from a generator is not a viable or safe solution. It is essential to repair the damaged phase of the electrical system to restore the balanced three-phase power supply. Consult with a qualified electrician to perform the necessary repairs and ensure compliance with all applicable electrical codes and regulations. This will protect your equipment, ensure the safety of personnel, and maintain the overall integrity of the electrical system.